we're going to talk about how we estimate uncertainties when we take measurements and how we can get those uncertainties to reflect the amount of random error that's involved in taking a reading or taking a measurement. And the amount of uncertainty that's involved or that reflects that measurement really is dependent on the measuring instrument that you're using and also how you use that instrument. So we're just going to first talk about an analog scale, and that's something which has got a scale, which is a physical scale that you can see, like this one, a voltmeter here, or a ruler. So when you take a measurement with an analog scale and the divisions are really closely spaced, and you can see here that it's got lots of divisions kind of packed into a tight space there, the uncertainty on an individual reading is plus or minus half that smallest division. So you could say in this reading here that it's about 53. It's probably as good as I can make it, 53.0 plus or minus half a division, which is 0.5. Now notice first of all that I have said that is 53.0. Usually when you look at a scale like this, you can kind of tell whether it's 53.0 or 53.5 or 54. So you can kind of estimate between divisions, but no better than to half a division. One thing that you'll notice over and over and again is that the value of your reading here is always quoted to the same number of decimal places as the uncertainty that you state. So if your uncertainty was plus or minus 1, we would only be able to quote that to 53. It's basically saying if we only know that value, if we have uncertainty in that value at that first decimal place where this 5.5 is, then we can't quote our final value to more decimal places than that. Again, this is for a ruler. Usually on a standard ruler, the divisions are 1 millimeter, so that's what we call the limit of reading. And so here we've said that the reading here is 4.20 plus or minus half a millimeter, which is 0.05 centimeters. Notice again that the reading and the uncertainty are quoted to the same number of decimal places. Now rulers and some other instruments are a bit tricky, and what happens is that we have, even if we're lining our object up with the 0, we actually find that there's an uncertainty at the beginning of that because we're not exactly sure that it's 0, and there's an uncertainty at the end of the object. And so we're essentially taking two readings here. We're saying that the 0 reading is 0 plus or minus half a millimeter, and the actual reading is 4.20 plus or minus half a millimeter. And so we actually have to add those two uncertainties together to say, well, it could be as much as 4.3, or it could be as small as 4.1. And so that uncertainty that's circled here gives us an idea about how well we know the number. If you've got an analog scale like this one where the divisions are really widely spaced, you can actually look at that pointer there and say, well, I know it to better than half of a division. I know it to better than 0.5 of a volt. I can actually estimate what makes sense, and it certainly tells you how sure you are about your answer. So I'm estimating that that reading is 12.2, and I think I'm uncertain by about 0.2 volts. It's pretty clear to me it's somewhere between 12 and 12.4. So you can do what makes sense depending on your reading, depending on your measurement technique. When you're taking a reading with a digital scale, So this is a digital scale now. It's a digital readout. The uncertainty is always plus or minus the smallest unit shown. And so here it only goes as far as the 1/100th of a unit place, and so that is our level of uncertainty. The exception to that rule is that if that digit is wobbling, so if it's varying quite a lot, say it's varying between, in this case, 0.14 and 0.18, then you can estimate that the uncertainty might be larger than the standard kind of 0.01. All right, so again, it's about what makes sense. Now, you may have noticed that in all of those examples, I've only ever quoted the uncertainty to one significant figure. There's no point, say, in estimating my uncertainty to be 0.015, because what I'm saying, if this is my uncertainty, is that I'm uncertain about this number in the 1/100th place. So of course I'm going to be uncertain about it in the 1,000th place. So that's not important. In fact, this brings me to another point, which is written down here. If for some reason I estimated my uncertainty to be 0.015, then I need to be conservative. Instead of, or just say it was 0.014 even, just say I estimated something or calculated something to have an uncertainty of 0.14, I would need to round that up to 0.2. So now we have the one significant figure and I've rounded up. Right, so uncertainties are always one significant figure and we always round them up.